Hi, in class we've talked about the three methods toString, equals, and compare to. This video will talk specifically about equals, and we are comparing one object to another with that. Just like toString, the signature is very specific. Here you want the driver to be able to access your equals method. It must return a Boolean. It must be called exactly all lowercase equals, and it's going to take any object that you want it to take. It can take a person, it can take a rectangle, it can take a circle, anything that you think is appropriate for your class. So you're going to define it for each class. And in this movie, I demonstrate what it might be to define the equals method for another triangle. But first, what I'm going to do is I'm going to show you what it would be like to use it in a driver. So once again, this is in the driver, and you have two triangles, and let's say that they're called triangle 1 and triangle 2. And you see up here in this part, that you only are going to accept one object. So where does the other object come from? Because equals, you compare two things, right? So one comes from the object that invokes the method equals, and the other comes from the object that is passed. And obviously, if we're trying to define this for two triangles, then a triangle will invoke it and a triangle will be passed. So let's look inside the triangle class what that might look like. You see the public and the Boolean and the equals, and in this particular one we're defining it for the triangle class. So like up here they say a generic object and they call it OBJ. We are making it for a particular triangle, and we are passing that triangle, and inside this method equals, it's going to be called T. So I make a local Boolean and call it flag, and I'm going to return that. So we need to remember to return a Boolean. So in this particular case, what I've decided is, are all the vertices equal? So a triangle has three vertices, and we are assuming that there is some way that the vertex is defined. And we are also assuming that it has a private data member, my vertex 1, my vertex 2, and my vertex 3. And we are saying, does my vertex equal t.getVertex? And what that means is t.getVertex is referring to the triangle that's passed, because this was called T. My vertex is the object that invokes it. So triangle 1 would be my vertex 1, my vertex 2, my vertex 3. It has access to its own private data members. And then this says, T, hey, go reach inside yours and grab your vertexes. And we're assuming in this particular case, since we're using the double equals here, that the value of my vertex is an integer or some primitive data type. So here's the logic in this. If all three pairs are equal to each other because they're ANDed together, then this will be true. Else, if any one of these are false, it'll kick out with short-circuiting and it will return false. Now in this slide, we were saying one integer value is equal to another integer value. Let's talk about tricky things with doubles. If you were in a math class and you were asked, is 25.00001 equal to 25.00002, you would say no. But what if you're doing some computation as a part of some computer program and you think that that is close enough? So maybe your tolerance is to the 10th place or the 100th place, and those would both round to 25, 0.0 or 00. For either one of those cases. So since doubles, and this is only specific to doubles and floats, since doubles can't be represented exactly, what we do is we set a tolerance. And so let's say that we are inside another class, and and it's the line class, and let's say that the line class is represented with the length of a line is some floating point number. So here we are again, we have public boolean equals, and the object that we want to define equals for, we have a boolean, local boolean declared. We are going to return that boolean, and it's a little bit more complicated because we need to set forth a tolerance. So let's have a double, and let's take the length of the past value versus the length of the object that invoked it. Okay, so this is similar to the other one. And let's subtract it and assign that to difference. And so let's say that we are interested in setting forth a tolerance of 1/1000th. When we subtract them, if the difference is greater than that, if there's more of a difference, then they are not considered equal. So we set the boolean, the local boolean, to false. But if the difference is not greater than 1/1000th, if it's less than that, then we are claiming that they are equal. So we set the flag to true. So if we return a true, then they are equal. If we return a false, they are not. So once again, to summarize, you as a programmer will decide what it means for one object to be equal to another object. That's it for equals.